Okay, buckaroos and buckarettes, this is a quick little video we're going to do here on this math pretest that we looked at, and I'm going to work through these one at a time. Each one of these questions here relates directly to a type of chemistry problem that we're going to have to do in the future. Okay, so we start here with this first one, integers number 1, and what we're talking about here is probably the best, quickest example would be when you're adding and subtracting, or adding or remove any electrons from atoms, okay, and that would be creating ions, okay, that would creating charged particles. So here we have a 0 minus 2 would give us a negative 2, obviously, right? Here we have a negative 3, and then we have minus a negative 2. When you have this minus backed up here with the negative sign, it's essentially a positive sign. So on your number line, that negative 3, you would go to the left 3 places, and that would leave you with a negative 1. Okay? Here you have a positive number and a positive number. You're subtracting a positive number from a positive number, so you're going to make this number smaller, and that is going to be a 1. Okay? 3 negative 2 is 1. Here you have a 1 minus a negative 1. So again, when you line those negative signs up, it's essentially adding numbers. So on your number line, that would be a 1, and you're subtracting from it a negative 1, so you're actually increasing the magnitude of that number. So that becomes a 2. Okay? Here, when we're talking about multiplying fractions, where you would relate this into chemistry is dimensional analysis, and you can look this up in your book or Google it or whatever and look and see what we're talking about. But basically we're talking about changing units, okay, or stoichiometry. And you can see that there's a whole unit on stoichiometry. But what we're going to do is we're going to multiply. We're going to use this system when we substitute those fractions like that. We're going to use a vertical line instead of that multiplication sign and just multiply in the numerator across. So 2 multiplied by 3 gives you 6, and 7 multiplied by 5 gives you 35. Okay, that number cannot be reduced, so that's your answer. Here again, we're going to take this number and very carefully, boom, 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 draw a horizontal. It's supposed to be a horizontal line there. 4 multiplied by 2 is 8, multiplied by 1 is 8, multiplied by 3 is 24. Do that in your calculator or do it in your head. 4 times 2 is 8, times 1 is 8, times 3 is 24. What's that? 3 times 5 is 15, times 2 is 30, times 3 is 90. So that is the correct answer. To reduce the fraction, you'd reduce it to 4 to 15. Okay? Now, in the algebraic expressions, whenever we have a chemical or a formula in chemistry that it's usually a chemical law or a physical law, and anyway, it can be reduced down to an equation. So in many cases, it's very important for us to be able to isolate the particular variable. In this case, what I would do, since we have a 3x on this side and a 2x on this side, is subtract 2x from both sides, and so you'd end up with x. Okay, you'd still have the plus 2 equals plus 1. Now I'd subtract 2 from both sides, and so 1 minus a positive 2 would give you a negative 1. Okay, so that's the first 7 there. Let's see, let's go on here. An example here, so we go 7, 8, 9. Okay, so 8 here is a little bit more difficult. What I would do is multiply both sides by 2. Okay, multiply both sides by 2, and that would give me 4x plus 6y equals 64. Now I would divide this by 4, and that would give me x plus 6 over 4, or 3 over 2y equals 64. Oops, 64 divided by 16. 64 divided by 4 would be 16. Okay, so that would give me x plus 3 over 2y, or 1.5y, equals 16. So now I would subtract the 3 over 2y, and I'd end up with x equals, I'll put it over here, x equals 16 minus 3 over 2y. Okay? Now question number 9, again we're solving for the variable x. So the first thing I would do is I would subtract b, and that would give me y minus b equals mx, and then I would divide by m, and that would give me y minus b over m. Okay? That is good. Okay, so now we go here to 10. This is actually a gas law problem where P is pressure and V is volume, N is number of moles, this is a constant, and T is the temperature. But we're just showing you that this is the type of thing you'd have to do. So if you were looking for the meaning of R, what R means in a gas situation, what it means is you would divide both sides by N times T, and what you'd end up with is that R equals PV over NT. Okay? Here we're solving for delta T. The delta means change in temperature, change in. So here what I would do is I would divide both sides by the mass and that specific heat, and that would give me Q over MC. Okay? So that would mean that delta T equals Q, which means energy, over mass times the specific heat. Okay? This is actually a problem, I think it's in chapter 12 or 13, where we use this equation where the energy equals the mass of the substance multiplied by the amount of energy required to change 1 gram 1 degree, and then this is the number of degrees that the temperature was changed. So these are actual formulas that we use. Here, and it's a little hard to do with your clickers, but here this is the standard conversion from Celsius to Fahrenheit, and the way I do it was boiling point. So we're going to say 1.8. If the boiling point's 212, 1.8 times 100 would be 180 plus 32. That's the way I remember it. But then if we kind of deconstruct it and take it backwards, what we would do is subtract 32 first. That's what I would do, is subtract 32 first, and then that would say that Fahrenheit minus 32, and in the order of operations you do that first, okay, would equal 1.8 times C. So then we would divide by 1.8, and you end up with C equals Fahrenheit minus 32, and you want your parentheses there because that's got to be done first, divided by 1.8. Okay? Now, here, I think I have these two on a separate page. Let's see. No. So here we've got density equals mass over volume. Well, most people got this correct, but there was a couple things I wanted to point out to you. We always want to show a specific the specific steps in order. The first step is to write the equation, rewrite the equation, okay? So the equation equals density equals mass over volume. Then you want to identify your variables, okay? The mass equals 12.00 grams, and the velocity equals 6.00 milliliters, okay? And so then the variable you're looking for is obviously density, so you're going to rearrange the equation if necessary, and this would be step 1, step 2, step 3. Step 4 is plug in the values, 12.00 grams over 6.00 milliliters. That's step 4. And then step 5 is solve for the answer, and of course it comes out to 2.00 grams per milliliter. Okay? Now, you notice you have 4 significant figures here. 1, 2, 3, 4. Here you have 1, 2, 3. Your answer can only be in as many significant figures as the value you were given with the least amount of significant figures. So you have 4 here and 3 here, so your answer has to be in 3. Okay? So the units are critical. Here we divided grams by milliliters. Of course, neither one cancels, so you got to leave both in your answer. And of course, if you're looking for density, which is mass over volume, you have to have both of those units. Okay? Now, see, I can't get quite down to 14, so we'll go back here. Let's see, and there's 14. So 14, same idea, just a little bit. We're just instead of solving for density, we're solving for volume. So step 1 is to write the equation D equals m over v. Okay. Step 2 is identify the variables. Your variables here, you have density identified as 4.00 grams per milliliter. And here you have the mass. You know it's the mass because it's given to you in volume, is 24.00 grams. Okay, that's step 2. 1, 2. Step 3 then is identify the unknown variable. In this case, it's volume, and you're going to rearrange the equation without using the numbers yet, so that you solve for v. And v then is going to equal m over d. That's step 3. Okay. Step 4 is you plug in the values, and your mass is 24 grams, 3 significant figures, 24 grams, and your density is 4.00 grams per milliliter. Step 5 is you solve for the answer. So this is going to equal 6.00, and the grams cancel. So you have 1 over milliliters. Well, as you refresh your algebra, you understand that 1 over milliliters will equal milliliters. And that is a good thing because we're solving for volume. Okay? So the volume here is 6.00 milliliters. Now in this case, significant figures are easy. Okay? We've got 1, 2, 3, 1, 2, 3. So your answer has to be in 1, 2, 3. Okay? And we'll go over this kind of stuff in great detail. But I want you to understand that these are the correct answers. Try to work through and figure out how I came to each one of these. And if you have any questions, don't hesitate to ask in class. I'll be glad to go over it. Alrighty? Good luck. Thanks.